Hello students, welcome to this video lecture on the subject analog and digital electronics. Today we will learn the Schmitt Trigger. Okay. Myself Gaur Gopal Jana, Assistant Professor, Department of Electronics and Communication Engineering, Greater Kolkata College of Engineering and Management. In the Schmitt Trigger circuit, first we will learn the definition of Schmitt Trigger. After that, the Schmitt Trigger circuit using transistors. Okay, the construction and operation of Schmitt Trigger circuit using transistors. After that, opamp based Schmitt Trigger circuits, under which there is two types of Schmitt Trigger circuit, that is inverting Schmitt Trigger circuit operation and non-inverting Schmitt Trigger circuit operation. And at last we will discuss the application of Schmitt Trigger circuit. So students, let us go to the topic. Okay. First, we have to know what is Schmitt Trigger. Okay. Schmitt Trigger is a comparator circuit with hysteresis, and it is implemented using positive feedback. Okay. Here, what do you mean by hysteresis? Here, hysteresis means it provides two different threshold voltage levels for rising and falling edges. Okay. It is an active circuit which converts an analog input to digital output signal. Okay. Now, why the name Schmitt Trigger? Because this circuit is invented by scientist Otto Schmitt in the year 1930. Okay. And the name trigger because the output retains its value until the input changes sufficiently to trigger a change. Okay. Therefore, you can say Schmitt Trigger is an electronic circuit with positive feedback which holds the output level till the input signal to comparator is higher than the threshold. Okay. It converts a sinusoidal or any analog signal to digital signal. Also, it exhibits hysteresis by which the output transition from high to low and low to high, which will at different threshold levels. Okay. Also, it is known as regenerative comparator because the operation of Schmitt Trigger requires an amplifier with positive feedback. Positive feedback means whose loop gain is greater than 1. Also, positive feedback is known as regenerative feedback. Hence, it is known as regenerative comparator. Okay. Here, this is an noisy input signal. Okay. Here, two threshold point, that is upper threshold point and the lower threshold point of the Schmitt Trigger converts it into a square pulse. Okay. So, the basic function of Schmitt Trigger, you can say, is to convert noisy square or sinusoidal signal or triangular pulse or any periodic signal into clean square pulse. Okay. With sharp falling and leading edge. Okay. So, by this way, we will get a smooth square pulse at the Schmitt Trigger output. Now, Schmitt Trigger using transistors. Okay. This is the Schmitt Trigger circuit using two NPN transistors. Okay. it is basically a bistable multivibrator circuit whose output is controlled by the input signal. Okay, so it can be used as a level detecting circuit. Okay, here the collector of transistor Q1 is connected to the base of transistor Q2. Okay, but as I told, the circuit looks like bistable multivibrator, but actually the output of Q2 is not connected to base of the transistor Q1. Okay, here input voltage is applied through a resistor RV to the base of the transistor Q1, and the emitter of both transistors is connected to that is ground potential through a emitter resistor RE. Okay, these emitter resistors act as a feedback circuit. Okay, also the V plus the DC voltage is used as a biasing voltage, and this V minus generally a ground potential, that is grounded. Okay, so this is the circuit diagram of Schmitt trigger using transistors. Now the operation of Schmitt trigger circuit. When the input applied voltage is 0, the transistor Q1 is in off state because it is an NPN transistor. So if this base voltage is 0, it is an off state. As it is off, then this collector voltage appears at the base of the transistor Q2. Therefore, the Q2 is in saturation region. Therefore, as it is on state, the output will be low. Okay. If we consider this collector to emitter voltage suppose 0, then the voltage across RE will be V plus by RC2 plus RE into RE. So voltage across RE is equal to V plus into RE divided by RC2 plus RE. So this voltage appears in the emitter of the transistor Q2. Now to conduct this transistor Q1, the input voltage must be greater than the summation of this voltage of this point plus base to emitter voltage drop, that is 0.7. So when the input voltage is greater than this total voltage, then the transistor Q1 will start to conduct. Okay, when it is in on state, then this is short circuited. Therefore, due to regenerative property, this will be in the off state, because as this voltage is nearly low voltage, nearly very low, that is as it is short circuited, which is equal to ground potential, this voltage appears at the base of the transistor Q2. Therefore, this will transform to off state. Therefore, the output V out is equal to high. Okay. Now the potential at this point will be this DC voltage V plus divided by RC1 plus RC2 into Re. Okay, so V plus into Re by Re plus Rc2. Okay, so in this configuration means when the Q2 is on off state and Q1 is on state, the voltage will be this. Okay, now this transistor will be conducting as long as the input voltage be in greater than or equal to this voltage, that is the voltage here plus the base to emitter voltage drop 0.7. Okay, so when input voltage V in falls below this value, the Q1 comes out of saturation, that is it will be off state. At the same time, the transistor Q2 driven to saturation state. Okay, that is on state. Therefore, the output states that is high and low are depends on these two values of input voltage. Okay. Now, if we plot the input and output voltage change graphically, then we will get two threshold point, that is lower threshold voltage and upper threshold voltage, also known as lower trip point and upper trip point. Okay, here the emitter to the base to emitter voltage drop, that is 0.7 is ignored. Therefore, we have got the upper threshold, the higher threshold voltage VT is equal to Re by Re plus Rc2 into V plus. Similarly, lower threshold voltage, as I earlier said, Re by Re plus Rc1 plus into V1. This is the transfer characteristics of Schmitt trigger, that is the plot of input voltage versus output voltage, and after plotting we have got the hysteresis loop. Okay, now what is hysteresis? It is the phenomenon by which the circuit triggers at a higher voltage for increasing voltage than the decreasing voltage. Okay, here we can see if we increase the input voltage, then at a voltage at which the output changes from low to high, that is known as upper threshold voltage. But if we decrease the input voltage, then the transition from high to low will occur at a different voltage. Therefore, we will get a hysteresis. Okay, this is the width of hysteresis. So this is the transfer characteristics of Schmitt trigger circuit. Now the opamp based Schmitt trigger circuit. Okay, since the Schmitt trigger circuit is essentially an amplifier with positive feedback, it is possible to implement this setup using operational amplifier. As we know that opamp has two input, that is inverting input and non-inverting input. So depending on where the input is applied, the opamp based Schmitt trigger is mainly two types. Okay, one is inverting Schmitt trigger and another one is non-inverting Schmitt trigger. Okay, now before going to the operation of inverting and non-inverting Schmitt trigger, we have to know the basic concept of opamp comparator. Okay, this is a circuit of opamp comparator. Here two input terminals, inverting and non-inverting terminals, and a output terminal V out. And as we know, the biasing voltage that is nearly equal to plus V sat and minus V saturation. Okay, So if the inverting terminal voltage is higher than the non-inverting terminal voltage, then output will be equal to minus Vsat. Okay, so negative saturation voltage. And when the voltage at non-inverting terminal is greater than the inverting terminal voltage, then output will be equal to plus Vsat, that is the biasing voltage here, plus 9 volt. Okay, so this is the concept of opamp comparator. Now this is the inverting Schmitt trigger using opamp. Okay, here why it is inverting? Because the input voltage is applied to the inverting terminal of the opamp. Okay, here this is the reference voltage that is applied to non-inverting terminal. This reference voltage is equal to V0 by R1 plus R2 into R2. Okay, so this is the reference voltage. Now suppose the output voltage is at plus Vsat. Okay, plus Vsat. We have earlier told that output, the op-amp output will be in two level. Okay, that is plus V, either plus Vsat or minus Vsat. Okay, suppose the output is in plus Vsat, so the reference voltage will be plus Vsat by R1 plus R2 into R2. Okay, now if the input signal increases and which is when slightly greater than this reference voltage, output will be changes from plus Vsat to minus Vsat. Okay, so here we have seen that if the input voltage increases over the upper trip point, then the output voltage will transition from plus Vsat to minus Vsat. So now the output voltage is minus Vsat and the reference voltage is minus Vsat by R1 plus R2 into R2. Therefore now the reference voltage is another one, that is known as lower threshold voltage. Okay, so the output remains in the minus Vsat value as long as the input signal is slightly less than this lower threshold, this reference voltage, which is equal to, as I told. Okay, so when the input voltage is less than this lower threshold point, then the output will changes from low value minus Vsat to plus Vsat. Okay, again now V reference is changes from the previous value, that is plus Vsat by R1 plus R2 into R2. So there is two threshold voltage. One is upper threshold and lower threshold voltage. Okay, so by which the output will changes states from minus Vsat to plus Vsat, again plus Vsat to minus Vsat. So we will get a square pulse. Okay, so this is the hysteresis loop of Schmitt trigger, that is Schmitt trigger hysteresis characteristics, that is input versus output plot. So here we have seen that when the input voltage changes from low to high value, at a value reaches when the output changes from plus Vsat to minus Vsat. Therefore this is known as the upper threshold voltage. But now if we decrease the input voltage, then in this point the output will not change. The output will changes another voltage, that is known as lower threshold voltage, in this voltage the output will transition from lower threshold to upper threshold. So this is the hysteresis loop. Okay, because the reference voltage will be changed due to this the output changes. Okay, so this is the transfer characteristics of Schmitt trigger. Now the non-inverting Schmitt trigger circuit. Okay, because here the input voltage is applied in the non-inverting terminal of the opamp, so it is non-inverting Schmitt trigger. Here initially we assume that the output voltage is in plus V set. Now by this plus V set we will get the lower threshold point. So until V in becomes less than this lower threshold voltage, the output stay at this plus V set value. Okay, when the input voltage falls below this lower threshold point, the output changes from V set to minus V set. So by this minus V set we will get the upper threshold volt. Okay, so the output will remain in this minus V set as long as the input voltage crosses this VUT, that is upper threshold voltage. So by changing this input, sinusoidal input, we will get a square pulse, but it is different from inverting terminal where the output waveforms is in opposite polarity. Okay, so here also this is the transfer characteristics of non-inverting Schmitt trigger. Here when we increases the input voltage, so after reaching at a point that is upper threshold point, the input changes from low to high value, but if we decrease the input voltage, then in another voltage that is in negative polarity will reaches when the output transition from high value, that is plus V set, to minus V set. So this is the hysteresis, and width of this hysteresis is equal to VUT minus VLT. Now the applications of Schmitt trigger. Okay, it is used to convert any type of input signal into corresponding square signal wave. Okay, so it can convert any type of input signal, that is sinusoidal signal, triangular, or sawtooth, or also the noisy signal, okay, into smooth square pulse or clear square pulse. And another application is it is used to eliminate chatter in comparators. What is chatter? A phenomenon where multiple output transitions are produced due to swinging of input signal through the threshold region. Also, this is act as an simple on-off controllers. Okay. Thus, hysteresis can be used in control system at detection level. Also, it can be used in debouncing switch. This is the references used in this video lecture, and if you have any question regarding this lecture topic, or if you have any difficulty to understand some portion of this lecture, then you may contact me through this email ID. Okay, so thank you, have a nice day.